Dart Skill presents Venn diagrams. Let's say we want to put the numbers from 1 through 12 in 4 groups: multiples of 2, multiples of 3, multiples of 4, and neither. So let's just name them: multiples of 2, multiples of 3, multiples of 4, and numbers that are neither multiples of 2 nor 3 nor 4. And we need to do the grouping in such a way so that when we put them all together and count them, we should get back 12, the original number of numbers. I said we are going to start with the numbers from 1 through 12. So there are 12 numbers. So 1 goes in here because it's neither a multiple of 2 nor 3 nor 4. 2 is here. 3 is here. Now how about 4? 4 is a multiple of 4 and 4 is also a multiple of 2. So where do we write that? Here or here? Or maybe in both circles. Let's do that. So we have a 4 here and we also have a 4 here. 5 is neither. 6 is a multiple of 2 and 3 both. So we're going to write a 6 here and a 6 here. 7 is neither. 8 again is between 2 and 4. So we have a 8. We have a 8. And a 8 here. 9 is a multiple of 3. So we have a 9 here. And then 10 is a multiple of 2 only. 11 is neither. And how about 12? 12 is a multiple of 2, a multiple of 3, and a multiple of 4. So we have a 12 here, a 12 here, and a 12 here. I think this should be a 10. Okay. It looks good. We got the right numbers in the right circles. But the problem is, when we add these numbers up, there are 6 in this circle. So you have 6 plus, you have 4 in this circle, plus 4, plus 3 in this one, and another 4 in this one. But that adds up to 17. We only have 12 numbers. And that's because, you would expect that, because we have repeated. For example, we have written a 4 here as well as here. We have a 6 in 2 places. We have a 8 in 2 places, a 4 in 2 places, and 12 actually is a part of all 3 circles because 12 is a multiple of 2, 3, and 4 at the same time. It's the LCM, or the least common multiple of these numbers. So this is not a good way to represent the data because I told you right at the beginning, when we count them up and add them, it should give you back the number of numbers, which is 12. And this is the kind of situation in which you find Venn diagrams useful. In a Venn diagram, we will make the circles overlap. And they're all contained in a big box. The big box is called the universal set. It's synonymous to the universe. Everything is inside the universal set. Nothing is outside the universal set. Now, if we go ahead and name the circles as multiples of 2, multiples of 3, and multiples of 4, we start with 1, and because 1 is not a part of any of these 3 circles, but it's still a part of the set that we started working with, we write a 1 here. It's a part of the universal set, but not a part of any of these. 2 goes in here. It's in this part of the circle. 3 goes in here. Now when we talk about 4, like we said, 4 is a multiple of 4 and 2 both. And therefore, to make that a part of both these circles, we are going to write that number 4 here. Now, if you look at this area, the small area out here, this portion is a part of the 2 circle as well as the 4 circle. And then we have a 5 over here. 5. And then 6 is a multiple of 2 and 3 both. In the same way, we are going to write a 6 here. This region out here is a part of the 2 and the 3 circles, both. So 6 comes in here. 7 is outside. 8 again is over here. Multiple of 2 and 4 both. 9 is only for 3. So 9 goes here. 10 is a multiple of 2 only out of these 3 numbers. So we write a 10 here. 11 is none. And then 12 is a part of all 3 which goes here. The small area out here that you see, if you look at that area, it's a part of the 2 circle. It falls inside that. It's a part of the 3 circle. It falls inside that, as well as a part of the 4 circle. So we write the number 12 here to indicate it's a common multiple between 2, 3 and 4, all 3 of them. And now if you count the total number of numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's exactly the number of numbers we have. And this is called a Venn diagram. Let's look at another example. Let's have 3 circles. And let's also have the universal set. And let's say this Venn diagram represents a group of people who speak French, German, or Spanish. And this, of course, is the universal set. And I'm going to put some numbers into these circles and ask you a few questions. So I'll put a 4 here, maybe a 1 here, a 3 here, a 2 here, a 5 here, and a 2 here, and a 6 here. Now let's try and answer a few questions by looking at this Venn diagram. How many people speak neither French, nor German, nor Spanish? It's 6 because it's a part of the universal set, but outside all the 3 circles. It's not a part of any of the circles. How many speak only French? The answer is 4, because this is the part of the circle that's exclusive to French only, and it's not a part of the other 2 circles. So only French is 4. Only German is 2. Only Spanish is 5. If you want to find out the number of people who speak, let's say, French and German, but not Spanish, so you want to exclude the Spanish circle that comes all the way up to here, but French and German, so it's going to be 1. And if you want to say, okay, how many people speak French and German? There's no mention about Spanish. That will be 4. Because there are 3 people who can speak all 3 languages. So that includes French and German, and there's only 1 person who can speak French and German but not Spanish. So French and German is 3 plus 1, 4. French and German but not Spanish is only 1. In the same way, German and Spanish is 3, but German and Spanish but not French is none. There's no number in this small area that's common to Spanish and German but outside the French circle. And common to French and Spanish, so how many people speak French and Spanish but not German? That's 2. French and Spanish both, that can also include French, Spanish and German. So French and Spanish is 5. French and Spanish only but not German is only 2. And of course all 3 languages, how many can speak all 3 languages is 3. Hope that helps.